We'll practice using Snell's law to find the index of refraction and then the speed of light in a medium. Here's the problem. A ray of light passes from air into a glass block. The angle of incidence is 40 degrees and the angle of refraction is 25 degrees. The speed of light in a vacuum is 3.0 times 10 to the 8 meters per second. Part A. Determine the index of refraction of the glass. Part B. Determine the speed of light in the glass. First, we use Snell's law. The index of refraction of air is 1.00. Snell's law says n air times sine of the incident angle equals n glass times sine of the refracted angle. Solving for n glass, we get n glass equals sine of 40 degrees divided by sine of 25 degrees. Sine of 40 degrees is 0.643, and sine of 25 degrees is 0.423. Dividing gives 1.52. Next, we find the speed of light in the glass using the formula V equals C over N. Plugging in C equals 3.0 times 10 to the 8 meters per second, and N equals 1.52. We get V equals 1.97 times 10 to the 8 meters per second. Rounding to two significant figures, the speed is 2.0 times 10 to the 8 meters per second. Remember, Snell's law relates angles and indices of refraction, and the speed of light in a medium is the speed in vacuum divided by the index.